I'm going to share. I have some slides on model risk management. So just to introduce the topic, and then Agus will take over. Let me share my screen. Yeah. Okay, so the topic today. So welcome everyone. Let me put this in slideshow. Welcome everyone. So today the topic is model risk management, in particular in the financial sector. So our guest is Agus Sudjianto. We'll give him a few minutes to settle in, but I'll introduce the topic, very like basic concept, and he will take over. So model. So AI is is everywhere. And when it is used in regulated industries, like in banks, there's the issue of risk management and AI model risk management. So you all heard about stories of of AI models giving wrong outputs or models that have been withdrawn. I think the most recent example is Gemini. Gemini, who started to put historical figures with different, color of skins, figures who are not historical, right? So these are the kind of model risks that you want to avoid. And in the financial sector, it involves not only hurting, feelings or sensitivities and shocking people, but also losing money, right? Losing customers' money or the bank's money. So this is also a very serious issue. So these are like a few examples of how AI and machine learning models are used in banks, in financial sector. So these are just like some examples. So this is used for fraud detection and prevention. So for credit cards, loan application, corporate frauds, Enron, these kind of things. You want this to you want to prevent this. It's used in risk and compliance. So we have what we call AML, anti-money laundering. For trading, you have market surveillance. You want to limit insider trading, for instance. For banks, there are a lot of capital regulation. So you have a capital requirement. For algorithmic trading, so when AI models are used for that, so there are risks. It's used for customer trade executions, price prediction, market fraud prevention. AI and ML can be used for credit risk management, loan underwriting. So it means like pricing a loan, sizing a loan. It's used for counterparty risk, calculate risk of default. This AI can be used for asset valuation. So it could be in fixed income, derivatives, liquid assets for loans, etc. Right? So it starts to be used everywhere. So this is like an example of a model life cycle. It's just to give you, and they're like, it's not a unique framework. It's just an example to illustrate. And so when you want to design an AI machine learning model, so typically you have what you call a design thinking phase, right? So you try to think, what do you want to achieve? Why is it like you want to try to predict the risk of default, right? You're going to explore the data. Okay, what data do we have? Do we have a historical of defaults of customers who don't pay back their loans, or banks or companies defaulting on their loans or their bonds, right? Then you start to think about, okay, what kind of models do I want to use, right? It could be like a linear regression model, could be a logit model, probit model, or could be a neural network, and so on. Feature engineering means like what kind of features, what kind of inputs am I going to use, right? If it's a company, I'm going to use balance sheet data, income statement data, or maybe beyond that. Then once you have selected the models, selected the features, some models like neural network models will select the features automatically. Then you have a phase of training, tuning and testing the model, and then validating the models. And then you have feedback. So you say, well, maybe results are not that great. So maybe we should want to revisit the assumptions and try other models, right? Then when it is pushed in production, you have to think in terms of what kind of data the model is going to ingest, data ingestion. You might want to train the model once in a while, not all the time, but once in a while it needs to be retrained. You have to think in terms of a real-time data input, the data feed. Look at the model production, and then you need to monitor the model. And then once in a while, do like a model performance review. Then, hold on. Okay, I'm going to make Prafulad our co-host is also here. Let me make him a co-host. Okay, Prafulad, you're also a co-host. Let me go back to the. We're talking about the life cycle. Yeah, so model monitoring, performance review, and get also the user feedback, right? So for instance, some users will say, well, the model is totally wrong, or in my questions, the results, right? So you can say, you don't give me the spread is too high, the interest rate is too high. Why is that? You know, my credit is excellent, and there's something wrong with it, right? So you get that feedback. So you have to always use that. Okay. Agus, tell me when you are ready, right? And then I'll stop. Yeah.
I am in the lobby hotel, so I'm ready. But my apology if my background is noisy, because I get caught in traffic. So I thought I will.
No worry. So let me go over like a couple of slides, then I'll introduce you. So these are so you saw the business side, the cycle. So let me just skip a few slides. So these are an example of risk and that we have that Agus team had to worry about, and maybe even beyond that. You have to worry about the quality of the inputs, of the output, the robustness of the model. Right? You change the inputs by a little bit. Are the results change? Are the results changing a lot? What is the objective? Security, cyber security? Are there any biases? Fairness issues? Are there like some particular groups unfairly, discriminated by the model because, for instance, you don't have enough historical data on that particular target? Is the model explainable? Explainability, issue of privacy, and about feedback. Okay. So on this, I'm to stop sharing my screen. Okay. Okay, hold on. Stop sharing. Okay. So this is to give you a color of the topic of today. So let me introduce you Agus Sudjianto. Right? So we are very fortunate to have him today. So he's the former executive vice president, head of model risk, and member of the management committee at Wells Fargo, where he was responsible for enterprise model risk management. Before joining Wells Fargo, he was a modeling analytics director and chief model risk officer at Lloyds Banking Group, a very big bank in the UK. Before Lloyds, he was an executive and head of quantitative risk at Bank of America. Right? So he worked for the major banks in the world. Interestingly, before banking, he was not always a banker. He was a product design manager in the Powertrain division of Ford, or the Ford Motor Company. He holds several US patents in both finance and engineering. He has published numerous technical papers. Maybe he'll mention some of them, very interesting papers that he has published in archive. And he's a co-author of a book on design and modeling for computer experiments. So his expertise includes quantitative risk, credit risk modeling, machine learning, and computational statistics. He holds a master's and doctorate degrees in engineering and management from Wayne State Universities and MIT in Cambridge, Massachusetts. So thank you, Agus. I give you the floor.
All right. I thought we're going to do more conversation
yes. So it'll be a conversation, but so maybe let me ask you maybe the first questions. So maybe tell us about I mean, I described briefly your career, but maybe tell us, in your own words, your career, what led you to AI risk management.
Right. So maybe I give, instead of telling a bit my career, probably give a little bit background, the recent one that we did. So for people that are not familiar with banking. So many of you that remember in 2008 is the big banking crisis in the US, right? So many of you that's old enough to remember that. The sky was falling at that time, right? Very, very scary time at that time. So, and part of the problem at that time was also blame on the model problem. If some of you remember, it was the Gaussian copula that used for pricing mortgage-backed security. So came out from that crisis, the regulator come up with expectation how to do model risk management for banks in the US. That is the guidance is called SR 11-7. So many of you are interested in, highly recommend to read. Google it, SR 11-7. And in that SR 11-7 is basically laying out how the model risk management should be done, the role of the board, the role of senior management, and the structure in the organization, and what to do, expectation on model development, expectation on model validation, and how to govern it. So that was in 2011. That's when I came back to that release in 2012. I came back to the US 2013 from UK as the head of model risk for Wells Fargo. So that's the inception, the early day of model risk management in banking. And it's very unique still until today, the only institution that model risk management is a requirement. So to give a little bit background in terms of model risk management, every bank have somebody like me as the chief model risk, and bank use a few thousand of model. Large bank like Wells Fargo, we use a few thousand of model. And when we use model, we are taking what we call it as model risk, because model may not be designed properly, and model, even a good model, can be misused. Just a lot of today's, many of you familiar with Gen AI, a lot of problem also coming from misuse. So the model itself problematic, and then it's a lot of misuse of the model. So those in financial institution, it can create very significant implication. If it's a financial model, which we do a lot, financial model, it can create financial loss, financial risk. And for global systemic institution, big bank in particular, if you have problem, you have trouble, it will create contagion and going to create a lot of problem in the economy of the national economy as well as the world. So many of you probably still fresh last year when we have problem with a few banks, Silicon Valley and all of those things. So I think that's still fresh for many of you. In 2008 is just the scale is much bigger. So managing model for bank is it's like a second nature, because we dealing financial model create financial risk. But we're also dealing with model that are not financial model. You mentioned about anti-money laundering, talking about fraud, you're talking about the trade surveillance. So So a lot of things that the bank use, even if you call, you lose your credit card, you call banks, it will be listened by banks machine learning to listen to the call, and the machine learning model will listen to it and looking at, is this call fraudulent or not, and helping the people who answer the call as well. So we use model for various for many things, for many things in the bank. And for non-functional model, it's also, it can create significant risk. Let me share with this. It can create a reputation risk. It can create it may violate law. It may have a lot of compliance problem. So those kind of situation, it can be very has serious implication too. So, for example, all of you are familiar with the Gemini problem. Google came out easy relatively because they just, they shut it down. Yeah, they have reputation risk problem. Their stock price get impacted, as you can see, right? Because of this. But if this is happening in financial institution, the repercussion, the implication, the consequence is a lot harder. It's because this is people talking about trusting their money, right? So it's a big deal. So the reputation risk for financial institution is really significant. It's a big deal, and also something that touch everybody, because everybody have their money, trust their money put in the bank. So so that's why model play very significant role for us. With that, then we have the discipline of what we call it model risk management. Just to give you an example of how we do it in this, I report to the chief risk officer of the bank. Chief risk officer report to the board directly. So have very senior people that independent. My team don't build model. My team in bank, it has model people that do model development, and then independently people that do model validation. Think of it, model validation is like the hacker, people that hacking the model, testing the model. For model development, say this model is good and things, you have people that will really destroy the model. Yeah, so we have in large bank like Wells Fargo, for every 3 model developer, it has 1 independent model validator. Every 3 model developer, 1 model validator. And model cannot go to production unless model validation approve it. And model validation can identify a lot of model weakness that has to be solved before model go to production. Or if it's not as severe, has to be resolved at a certain time. They can put in production, but it has to be resolved for a certain time and has all the mitigation, what are the mitigation and all those things. So in institution like bank, every model has to be tested. Every model has to be independently validated, independently tested. Every model has to be hacked first by independent person. And they report to different people, right? All this model validator report to me, who report to chief risk officer, who report to board directly. Independent. So we don't report to the business. No conflict of interest, pressure of deploying model. So we don't deploy model. We test, we make sure the model is safe for use. The model will not create harm to the company, or the model will not create harm to the customer, or at least you understand the risk, and then you know how to manage the risk. And this happened for every model. And then model has to be monitored all the time. Model is monitored, and the model validation will look at that result of monitoring as well. For every change in the model, has to go back to model validation to get validated and tested. So that discipline is there. So for this is happening for every single model. So every single model, we have model inventory, we have system, we know exactly the performance of the model, we have the documentation. So in the documentation in banks, it will have two documentation: model documentation from model developer, and from based on that model documentation, independent person, model validator, should be able to read that document and replicate that model, independently replicate and test it. So then model validator will come up with their own report called model validation. Chapter per chapter, section per section will be the same, but showing how the view of independent testing, independent validation on that.
I have a question, I guess, on the definition of models. Like, for instance, many bankers will use like Excel, right? And they could have like, you know, like even large models coded in VBA or, you know, to price, you know, loans, all these kind of things. Do you also validate these models? Or
absolutely, yes, everything. So we have very specific definition of model. If you have outcome uncertainty, it's model. So, and that can be deployed through Excel, through C++, if it's trading model, or in Python, if a lot of machine learning in them. So the deployment, it can be anything, including Excel model that deployed in Excel.
They be like anything, tens of thousands of models, no?
A lot of model, yeah. And every one of them have to go through this process that I spoke about. Every one of them has to monitor. If they are finding, have issue, has to be solved, has to be managed. So we have an inventory system that hosts all of this, and model developer, model user, model owner, model validator use all this system, a single source of system that we know exactly everything that's happening in that model and the model, the status, everything. So, and that we report has a very, very high level visibility too, because I have to report to the board, I have to report to the top of the house in terms of the status of the model as a whole. And if you have a few thousand, we report the statistics, what's going on, what do we worry about. So of course, when we have a lot of model like we do, not all model are created equal. So we tier them. Some of them we call it tier 1, which is the most important model for the company, because the risk is higher in terms of either financial or non-financial risk. And then we have tier 2, tier 3, tier 4. So we have different tier. With different tier, the scrutiny will be different. The expectation will be very, very different. Right?
What would be an example of tier 1 and tier 4, for instance, models?
Yeah. Tier 4, for example, are a lot of more operational model. Let's say, how many tellers do we need to put in a bank branch, right? Tier 1 is, for example, how much credit loss we're going to have in our mortgage portfolio. Yeah. So depend on the materiality and the impact of the bank. Is this model can break the bank? That's tier 1. Yeah. If the model wrong, it won't break the bank. That's lower tier. So at the end of the day, is the impact of this model. Some of them impact in probably not financial, but the impact can be reputation. So model, for example, we have model that do complaint handling, right? The big bank like Citi, like JP Morgan, like Wells Fargo, receive a lot of million phone call from customer every month, and many of those are complaint. And complaint will be, if you make the phone call, will be voice to text translation, and then you have your language model to process that complaint, to either to summarize it or to route it to the right people to get solved. Those are very, very important things. For example, complaint in a bank, this is interesting. From the minute you complain to the bank to the resolution, bank has 10 days, have to be solved. No other industry have this requirement, right? But for bank, has to be solved within 10 days.
And this is tier 1 model. Is it tier 1 model?
This is, yeah. It can be tier 1 or tier 2, depending on which states of things. So very important model like that, then will be very high tier. Very important model.
This is an interesting example, because using NLP, right? So it's a kind of AI machine learning models. So how has your job changed with the introduction of more like machine learning, NLP models in
Right.
banking.
Yeah.
This is
Yeah.
relatively new. I mean, maybe not.
Right.
I mean, NLP, that I think banks have been using it for a while, like,
Yes.
but the models are a bit different, right, with AI now.
Yeah. Yeah. Well, machine learning, we'll talk about that a little bit before we go to that and what changed. Yeah. When we talk about validating model, what is it? Model validation, right? If you read SR 11.7, it has three components in the what constitute model validation. One is evaluation of conceptual soundness. Is the model conceptually sound? We'll talk about that a little bit. Conceptual soundness. Two is outcome analysis. The testing of the outcome. We'll talk about that in a bit detail. And the third is ongoing monitoring, because we have to do this in ongoing. So three components in model validation: conceptual soundness evaluation, outcome analysis, and ongoing monitoring. Now, what's constitute conceptual soundness? And this is very important, conceptual soundness. One, start with, is the data appropriate? So you talk about privacy, security, and all those, and also, is the data appropriate for this particular use? So bank will not do like what people do in LLM. Just download the data from internet and tokenize it and use it, because that's not appropriate. So start from the data first. Some information can and cannot be used. So that's privacy and all those legal requirements and all of this, what data can and cannot be used. And then is the data represent your customer? So data appropriateness, data suitability, data quality is the first element on conceptual soundness, because if you don't do that, you will not pass. You will garbage in, garbage out. So that first on the data. Two, variable selection. What variable you're going to use? Some variable you can and you cannot. A lot of variable you cannot, because that's variable, particularly for a regulated area like credit scoring. A lot of limitation, a lot of data cannot be used. For example, geographic information cannot be used, because that will be discriminatory.
Like
Even
zip code
yeah, zip code cannot be used. Location cannot be used, because that will be discriminatory. For example, another example, mortgage size, how big the mortgage, that cannot be used for credit decision. Why? Because mortgage size is a proxy to zip code, and then will be discriminatory. Even if mortgage size very predictive for whether a person that have credit card will default or default, cannot be used. It cannot, because mortgage size is a proxy to protected class, to race, because it impacts, it will be zip code, and zip code is related to a demographic. So a lot of restriction. So what variable can and cannot be used, and then the variable selection. Then after that, we talk about a part of the conceptual soundness is explainability. Is the model make sense?
I guess Prafula, our co-host, has a question for you.
Go ahead.
Go ahead, Prafula.
As regards variable selection, in AI developed models, isn't the variable selection automatic by the algorithm?
No.
How do you tell the algorithm what to use and what not to use?
No. You start with variable that can or cannot be used legally, compliance and requirement, data governance. Yeah, not all variable can be used for certain purposes. Very regulated. Now, once this is all the variable that's allowed, then you can do variable selection automatically using machine learning. But the variable is allowed first. Yeah, one is allowed. Okay, this is the domain that you can use. Now you can throw in your model, do variable selection using machine learning algorithmically. You can do that, but we don't do that blindly too, because it has to pass two things in variable selection. is this make sense from business point of view? 2 is the variable causal. So do causality testing. In some area, it's very important to do causality testing. We'll talk about that a little bit later. But yes, you can use it algorithmically for exploratory thing, but then you have to say, does it make sense? And then some causal testing too that you probably need to have to do in certain application. Once you do,
yeah, go ahead, man.
The other thing that's important is the issue of explainability. Now, what is the effect of variable to the output? We need to know that. And how is the effect make sense? So if you just run, let's say, gradient boosting machine, you get the good one. You probably do a PDP plot. Is the PD plot the effect makes sense? If say it's the very and XGBoost or gradient boosting machine can easily overfit, you can see it. Well, it has the effect is not monotonic. Then it doesn't make sense. So you need to make it monotonic. So explainability is very important to evaluate whether the model conceptually is sound or not. Because in machine learning,
do the regulators have enough AI competence to
absolutely
review the models?
Yes, the OCC has OCC red team that's full of PhD. Yeah, but the onus is on the bank. The model validation, independent model validation, which an army of PhD. This is a company like Wells Fargo or Citi or JP Morgan or Bank of America. This like 300 plus people in just the job is day in and day out is testing model, right? So you look at this and you see this is regulator rely on model validation, internal governance. Do they do a good job on doing all this testing and looking at the explainability and all of those things? So for some application, the model explainability has to be exact. It cannot be using PDP. It cannot be using Lime or SHAP. For some application, highly critical, we need to be certain, because all of this post hoc explainability tool are approximation. So with that, then you have to architect your machine learning model so that inherently interpretable. Yes, you can still use gradient boosting machine. You can still use neural networks, but need to be very, very interpretable. And for some of you that interested in that, you can Google PIML, Python Interpretable Machine Learning, PIML. You should take you to a GitHub of the tool that my team released out there that people use for highly important, high risk application, building machine learning that's inherently interpretable.
Agus, Mahesh has a question for you. Mahesh, go ahead.
Yeah. Yes, thank you. So you have already evaluated the risk. You have a pretty definitive model. Everything is going hunky-dory. And then the firm goes and acquires something like Wachovia Bank, where you do not know what its credit risk is, and your model is now you need to rebuild. How do you go about it under those circumstances?
Yeah, but bank do a lot of acquisition and all of those things. Part of the acquisition, you have to get the data, you evaluate the model, all those model has to go through governance. The same thing. And not only when bank acquire other company, every third-party model has to go through the same process. Yeah, if bank purchase model from outside, it has to go through the same process. It will go through this. So I'm talking about then. Let me finish on the conceptual soundness. So we have explainability. Then we have what we call it benchmarking, meaning we have to compare it with other model to understand the characteristic and compare. Yeah. So conceptual soundness has 4 components: data, variable selection, variable effect, explainability, which is variable effect and explainability, and then benchmarking. And then outcome analysis. This is very important outcome analysis. This is problematic in machine learning, very problematic, because the school and the education only teach very rudimentary stuff. What you do in build machine learning, what do? We split the data, training and testing. We build model with training data, and we test it with testing data. And then you look at performance, AUC, precision, recall, or RMSE, and you're done. That is not what model validation is. That's not what model testing. Model testing has 4 components. 1, understanding model weakness. Which condition, which situation that the performance of the model will be weaker, because that's where model will fail. So understanding where the model is weak is very important. 2, looking at reliability. How certain the outcome of the model. We need to understand the uncertainty of model outcome and understand what region, what condition in the operating of the model where the uncertainty is higher, because there's also model weakness. So prediction uncertainty is very important. Then we isolate, we identify which condition, which range of variable, what variable combination, what range, where the uncertainty is higher. That's reliability. 3rd is robustness. Input has noise, and noise change. So is the model sensitive to noise or not? And this is the big problem with machine learning, because when you build machine learning, you assume IID. You split the data randomly. So the noise is the same. So when you overfit, which XGBoost does, or a gradient boosting machine does frequently, and a lot of machine learning will do this because machine learning is overly parameterized. You test it with testing data, still looks very good. You deploy it in production, performance drop. Why? Because the real world, the noise is different from the performance from your data that you build. So testing for robustness is super important. Injecting noise to on the testing data to see how model is robust. It's very important to detect what we call it as benign overfitting, because unless you do that, you have overfit model. So testing for robustness is important. 4th, testing for distribution shift. Under distribution shift, what distribution shift that will degrade the model performance the most, so that we know how to monitor. So 4 testing: weakness detection, reliability, robustness, and resilience. We call it resilience because that's environment change distribution shift.
So
These are the...
So I guess let's take an example. Let's say that in terms of third-party model, let's say that the CEO decides to subscribe to ChatGPT, right? So okay, everybody, like I think Citadel Securities, I think Ken Griffin, like many other hedge funds are subscribing to ChatGPT or version of that, and they deploy it within the bank or the fund. So you are the model risk manager. How would you apply your methodology to assess ChatGPT?
Oh, the same thing. Yeah. So let's talk about language model. Okay. So, but before answering that, let me finish.
Okay.
So we have 4 testing for conceptual soundness, 4 testing for outcome analysis, and then the test number 9 is model fairness. Yeah. So 9 testing. Every model with fairness every model go to 8 testing, and then for certain model that fairness need to be tested, you apply to the test number 9 is the as the fairness. Now, how are we doing with language model? We're doing the same thing on the language model. Then I'll talk about the third party. The only difference in language model is variable selection. Yeah, it's not variable selection. It is variable selection if it's for classification. But if it's like Gen AI, is instead of variable selection, what is the variable selection? Is prompt design. Yeah, the equivalent of variable selection is prompt design. Okay, but the rest are the same testing. So now how do we do with the with Gen AI? So because in Gen AI we have pre-trained model, right? How do we do what do you mean by data applicability? Well, if you fine-tune the model, you look at the fine-tuning data that used for fine-tuning. If you don't fine-tune, you do zero shot for X and all of those things. Then you look at the data for testing. What data is the data for testing are comprehensive enough to do all of this? So that's example of that. So with ChatGPT, it's the same thing. We're going to test it. Okay, how are you going to test it? Are we going to use it for certain purpose? Or how are we going to test it? So and then depending on some vendor model, we can do testing on the conceptual soundness. Some will be more difficult. If you cannot do conceptual soundness, at least you have to run testing on the outcome analysis, because outcome analysis you can do them all. Understanding model weakness, yeah, we can do that by understanding model weakness very easily. You test it with various prompts. If you use it for X system, for example, you have your document, you have chunk of your document, you can cluster your document, and you can see which retrieval summarization of a certain chunk that is the weaker. So yes, we can do it. Robustness, we can do that, for example, because I give prompt and I perturb the prompt. Right.
And when you validate this like the deployment of, let's say, ChatGPT within the bank, what accuracy rate is acceptable? Because they have error rates, even you use RAG and so on. What level is acceptable on
Right. First of all, we don't use ChatGPT. Yeah, this is a disclosure. We don't use ChatGPT. We don't use the API-based call because we don't want any data go out.
Mm-hmm.
That's not allowed. Any data to go out of bank system. So not allowed. That's why we don't use ChatGPT. So the talking about data privacy, security, and all of those things. That's why bank use model that's internal only. Data don't go out. So that's how we use it. We can use data that we can use that API base if no bank data are being used. For example, somebody going to use it for research of large corporate, then you can hit Moody's, or you can use FactSet or FactSet or any of those things that you can use, but it's no bank data, right? So that's they have to be very careful on that. All the testing, like I said, has all applicable. I can test the prompt, sensitivity to prompt changes, and to perturbation of prompt. When we say perturbation, we say perturbation invariance. So then I'll answer your question. You perturb it invariance perturbation, you do perturb it in adversarial perturbation, and you look at all of this and look at the result, and you look at a whole slew of metrics, right? So when we validate this, we have a lot of metrics. For example, let's say if it's RAG, you have the precision recall and all of those things on the retrieval side, and then on the summarization, even RAG, you still have to test for hallucination, right? You test for relevancy of the summary to the context. You look at the relevancy of the output to the query. You look at all of those. Now, how much is acceptable? This is very fundamental at the beginning of model validation. Because at the model validation, the key is, remember, model are used for specific purpose. Model used for specific purpose. The first question in model validation is, what is the key model risk? The key model risk is, what is the harm if the model is wrong? So model owner, people who's going to use the model, need to be able to state that. What is the harm if the model gave you wrong answer? And then the second question is the risk appetite. How are you going to measure it? And what is the level of acceptance, the acceptance criteria? And that's depend on use per use, depend on the criticality of use, right? So you have to state the key model risk. Then you have that key model risk basically is failure mode. What can go wrong? And if that's wrong, what is the damage? Clearly, Google didn't do this, right? Because they don't think about what's the key model risk. Okay, what can go wrong? What the failure
I
mode?
think that in the case of Google, they wanted to manage another risk. I think this kind of they want. I think this it came from like trying to correct biases, right, in machine learning models. So it started from a good intent, but then they,
but it's also what can go wrong, right?
yes,
The the road to hell paved with all good intention. Yeah, it's always in model world. In the model world, yeah, the model world, the road to hell is paved with all the good intention.
Yeah.
And that's what people need to think about. And then think about, okay, what is the acceptance? What can go wrong? How wrong can it? What's the acceptance criteria that will be challenged by model validation? And then how this thing can go wrong and how wrong can it be? That's what model validation is. Hacking the model, showing how wrong can it be, how bad can it be.
Yeah, we talk
Clearly,
about
somebody didn't do that job in some situation.
We talk about validation, and you're talking about post hoc, methods of explaining models. So, what lessons should we learn for people who are developing models? Because so maybe it might not be the right model to develop the model, then deliver it to model risk management at the end, and then wait for validation. Maybe they should try to incorporate some like sound methodologies from the start, from the beginning. So do you
Absolutely.
have any recommendations?
Absolutely. Yeah, absolutely. Absolutely. So conceptual soundness, designing, you talk about design mindset from the beginning, right? So you design it from the beginning. I used to design car engine. I used to design an engine for Ford Motor Company, right? We always have very clear design intention. So we cannot just put model haphazardly. The problem with the machine learning today is because it's so easy to build. You just call an API, call scikit-learn, or call anything, use PyTorch to run, and you get model. Or even worse today, download something from Hugging Face and start with that. That's no design thinking in that aspect. So the design thinking is very, very important when you want to design it right, and then you test it. So I talk about those 9 disciplines of testing. By the way, all of those elements of testing, 9 of them, if you want to learn it, we put it for tabular data in PyML. That's used for tabular data. That's an example of real world testing. Yeah, the real thing. So you're not just looking at overall model performance, but we're looking all of these aspects. So you want to build and design a reliable model for real application in the high stake environment. Take a look at the PyML in all those disciplines, because that's an example from real world. So we put it out there so that people are aware when we do machine learning. This is what we're thinking about. This is what we do. Yeah. Same thing on language model. No difference on language model.
So in the design thinking, there's that collaboration between the stakeholders, right? You have the modelers, you have the end users,
absolutely,
risk managers. And so do you have any thought about this and what can go wrong?
Yeah.
Or what best practice?
It for us, because bank has been doing modeling forever, right? So it's a second nature to do that, right? Because like I said, what is the purpose? Because you have to start with what is the purpose of the model? What is exactly the purpose of model? Remember, I asked about the key model risk. That's a statement from model owner, model user. In the model development documentation has to be clear. It's not clear, it's not going to get validated. Because what am I going to validate? So we cannot validate a pre-trained model because it's not clear. What are you going to use it? What are you going to validate it for? Nothing. You cannot validate pre-trained model. It become a model for a specific use, then we can validate it. validated for specific use. Then we can test it. That's just to be able to do this. It's really the collaboration from the beginning. And when we talk about collaboration, is collaboration of many things, because hey, we have model developer, we have the business side model owner and the business side. We have model validator, but not only that, we have the compliance team that need to check whether this is from the beginning, because you don't want to build model and the compliance team will reject it later because you violated compliance rule. In some situation, the legal also need to get involved. And then the data governance, the chief data officer office, as well as the technology partner, because technology will deploy the model, right? We'll put the model into production. So it's all the collaboration of all of these that has to happen from the beginning, from the before even start the model, before even model will be built.
Okay, so so we talk about model development, validation. So the phase after that, once the model is validated, you have monitoring and maintenance of models. So what can you? What are your thoughts about that?
Yeah. So I talk about model validation. Now, model will change all the time in the life cycle, whether it's going to be retrained, right? Or it's going to be modified, because if it's chatbot, hey, you're going to be able to answer certain thing, you get chatbot will get updated. So that is the discipline of change control, because every model change has to go through model validation again. Now, even there is no change, it has ongoing performance monitoring, right? So ongoing performance monitoring. And even without any change, we also have periodic testing. So doing all those model validation, now we do it in more regular basis.
There's a good example of GPT-4. I think that the users have noticed a decrease in performance. So the people have been complaining that GPT-4 has become lazy. The answers are different. So you ask the same questions, and now the answer more recently have been shorter, not as detailed.
Right.
So this is a good example of living models that that needs to be monitored.
Absolutely. And in our case, like I talk about the model risk system, the the system, the central system that we have on the model management. That's tracking every change, any change in the model, any version, any change. If it get retrained, if it's get updated, it's all tracked in there and inform everybody. The system will inform, right? If things change, model validation work need to get done, and all of those things. So we have, when practicing model risk management, all of these are already in the machinery to be able as a business as usual. And the challenge is also how can we do all of this in more streamlined and efficient way, automated testing, and all of those things that people can deploy, so that the discipline of model risk management happen all the time.
I think recently, also I think last week or 2 weeks ago, they did exactly something that you mentioned. They made a change on ChatGPT, so they introduced a bug, and suddenly ChatGPT started to give crazy answers. Right? So something.
So that's the problem with using. You have to be careful when using a external model like that. We always have an agreement in things. If any change in the model, you need to let us know so that model testing can be done again. So that's change management discipline that need to be instilled.
And I have another question that we're going towards the end of the talk. What is your recommendation of balancing innovation and risk management? Because you want to innovate, you want to try new tools, but at the same time have risk control and so on. So what's the
absolutely. This is the key of what happened in the model risk management team, the model validation. Model validation need to serve as the research arm of the company. They are ahead, so that they can facilitate innovation. And when a new thing coming, we know exactly how to test. This is my big problem with LLM, by the way, criticism of people out there. People out there rushing to deploy without knowing how to test. Now, the role of model validation to be ahead of the curve. So when machine learning becoming popular, we work on this. What is most important in this? Oh, at the beginning, in the 2015, explainability will be big deal at that time, right? It will be big deal. So we built a methodology to have explainable machine learning. So we built methodology, we built series of testing so that, yep, you come, we're ready. So it's the role of model validation to enable innovation. If I can share with you, in Wells Fargo, the research and development team, the R&D team, is in my team. Second line. Yeah, because you need to innovate, you need to be ahead so that you can facilitate for people to move fast.
It's not very common.
So,
it's not a very common setup in that.
I don't know, but that's what we success. It's not very common, honestly, but that's what the success that we do. So we can release tools that enable easy testing, ready testing. For example, today on the Gen AI, we have very extensive library for testing, so that people will not make mistake. We encourage innovation, but that means the MRM team need to be really ahead of the curve.
You go ahead, Prafula. Yeah, the question.
I had one more question. That, if you try to distinguish between the model risk management approaches or model risk management methods with and without AI, what would be the difference? I mean, things like
Yeah,
BC 13-5,
I give you some.
all of them will apply, right?
Yeah, all of them will apply, but the techniques to do it are different. For example, model robustness. Model robustness is uniquely AI because overly parameterized model. And you can read our paper, you can read my paper in archive, enhancing robustness of gradient boosting machine as an example, but it's applicable to deep neural network as well. So it's uniquely for parameterized model.
I think we lost.
Yeah, Agus is frozen.
Am I frozen?
Yeah, you're frozen. Now you're back. You're back. Yeah.
Okay, sorry about that. So the requirements are the same. The techniques are different.
Yeah. So what are the differences in techniques?
Yeah, I give you example.
Yeah.
The explainability techniques, right? The explainability techniques are different. The robustness techniques with the simple statistical model, because they are not overly parameterized, they're always robust against small noise perturbation. Okay, machine learning, it will be non-robust against small perturbation. So that's an example of that.
I see.
Yeah, and language model is high dimensional feature. The input is embedding, output is also represented in the embedding dimension, very high dimension. So the explainability techniques will be different.
I see.
I have my last question is, what are your thoughts about the ethics of using AI in banks and ethics and work, ethics and jobs? Is it
Yeah.
Is the senior management thinking about this? Or just thinking
absolutely.
Yeah.
For us, the Gen AI, in particular on the AI, bank, some area are very regulated. Discrimination, fair lending, those have regulation. You cannot pass that one because you're going to violate law, right? Some area are very clear because it has law. Other area don't have law, but it carry reputation. So for us, for every AI model, it has to go through what we call it AI SWOT team, looking at risk assessment across. Is this something that we're going to do? For example, if you want to do resume screening using AI, we will just say, no, we are not going to do it. We're not going to apply AI for any hiring, for any hiring practice.
Hmm.
That's the decision that we make, because that will go to a lot of problems. Are we going to apply a certain thing? Let's say we want to do ChatGPT, for example. Then we have a lot of talk about this, not only on the ethics, but also talk about how are we going to do it legal on the intellectual property? Is this something that we're going to do? I give you an example. During COVID, for example, at the beginning during COVID, somebody say, let's build model, epidemiologist model, to decide whether banking center is going to be open and closed. We will say, nope, we're not going to do it, because that is going to be problematic. So that kind of decision happen upfront. If I say no, it will be no, right? But it also get elevated to senior management to say whether we're going to do it or not.
Okay, thank you. Let me open the floor to 1 or 2 questions. If you want to have the questions to Dr. Sudjianto, please raise your hand. If not, I mean, I've been starting to read your latest paper. I mean, I know it's not your latest paper. One paper that you have, like designing inherently interpretable machine learning models. I find it like very interesting. Right? And you cite many of your work and past papers. So I encourage everybody to read it. I think there's a GitHub maybe depository there too. And so it's very, very interesting reading.
So look at the PyML. So those are the paper, but the tool, the software is in PyML, free access under Apache 2.0, so everybody can use it. And a lot of banks using it, by the way. A lot of institutions use PyML.
Okay, excellent. Okay, so but thank you very much. It was very informative. You know, you have very rich experience, and I wish you good luck for your future ventures. And I hope that we'll talk again and meet in person one day.
All right.
Okay.
Excellent. Thank you so much, man. Thank you, everybody.
Okay, thank you, everyone. Okay, goodbye. See you next month.
All right. Bye.
Bye-bye.